This one is going to be quadratic inequalities. New step. Ready? Here we go. Graphing quadratic inequalities. It's very, very similar to graphing linear inequalities. All right. Now, if you don't remember, because they were way, way, way back in early September, mid-September, something like that, you would have an axis like this. You'd have a line like this. And then you would do what?
Pick out points.
Pick out points, test them, and then shade accordingly, right? Okay, shade either this side or maybe this side, just depends, all right? Basically, we're going to do the exact same thing, except your line is going to be a quadratic, a parabola. Same deal, though, all right? So that's why the first bullet says, you can graph quadratic inequalities with the same techniques used to graph linear inequalities. Those steps are as follows. Number 1, graph the related function. Number 2, test a point that is not on the parabola. That still holds true. Okay, that test point can't lie on the boundary. Step 3, shade accordingly. If your test point was true, you shade towards that point. If your test point was false, you shade away from that point. Alrighty? But same steps, same 3 steps basically. On your homework tonight, you're going to get a worksheet for your book problems. Your homework's actually in the book. I'm going to give you a worksheet to do it on. So you'll have graphs for your homework. You'll have graphs for your tests. But for this, you'll just have to make a quick one, okay? You can still, like graphing it, you can still use your table function on your calculators. Okay, that's still all right. So you go ahead, you get that table from the function y equals x squared plus 2x plus 1. All right, and I'm going to go ahead and save you the time. Your points are negative 1, 0, 0, 1, negative 2, 1, 1, 4, and negative 3, 4. So you go ahead and plot those points.
Did you say negative 2, 1?
Yes. Bless you. So negative 1, 0 right there. 0, 1, and 2, 1 right there. 1, 4, and 3, 4 right there. Your next step is to actually graph it, okay? But here's where this can be. This is actually, I think, the trickiest part of the whole thing. What type of line do you use on this parabola? Curved one, okay. That's like whenever you say what type of line, you guys all said straight. I go, no kidding, they're all straight. What's the differences?
There's a point or
Dotted.
There you go. Why dotted, O'Neill?
Because it's not including it.
Very good. It's strictly greater than up on top. So you have to draw this parabola with a dashed line, which can be a little challenging sometimes. Okay? So just take a little bit of time. Like I said, I'm not looking for perfection on it. Just show me enough that you know, that I know that you know what you're doing. Okay? Everybody good? So that's the first step. Step 2, we're going to test that point. You can still use any point not on the parabola. Just got to make sure it's definitely not there. So I'm going to go to my fave, which is the origin, and you're going to plug it in. So 0 greater than 0 squared plus 2 times 0 plus 1. Simplifying down to 0 greater than 1, which is false. So we're not going to shade towards that point. We're going to shade away from that point, which ends up being inside the parabola.
Wait, are you actually inside the parabola and outside?
Yes.
Okay.
That's those.
You tested negative 1, 0, right?
We tested 0, 0.
Yeah.
Negative 1, 0 is your vertex.
You can't test what's on the
No, correct. Okay, so think about, and like I said, Mikhail is exactly right. Your options are inside the parabola or outside the parabola.
What does it look like if it's outside?
You shade everything else.
Oh.
Okay, but think about what's going on, like grand scheme things here, right? The parabola extends on forever and ever this way, right? Okay, so as you keep moving up this way, and these arms keep branching out and out, you get a bigger shaded region up towards infinity as you push towards infinity. Okay, so it's not. So it looks like, okay, cool, I just shaded this itty bitty region. Yeah, but remember, you're pushing to infinity, and that region's getting bigger. Okay. Yes, that's 100% correct. If you were to shade the outside, I expect to see, this is wrong, that's why it's going to be in blue. That. Doesn't have to be extravagant. Please don't wear a hole through your paper, because that's been done before. Okay? But yeah, just shade a little bit. All right? Now, this slide I put on here, you don't need to really write all this down. This is in the book. Okay, it's around page 286. It's probably not exact 286, and I'm too lazy to go look up what it actually is. But basically what this page in this book does is it talks about once you start moving away from solving them with, like, from a graph standpoint, from a function standpoint, graphically, into solving them algebraically. Okay? What you're looking for without the shaded are what? Let's start with this. Let's back up. What are the answers to a quadratic?
Where it hits the 2 points where it hits the
X what? Axis. Good. The 2 points that hits the x-axis. Whenever we did equations, when we factored and we solved them, those were those 2 points, right? Everybody remember that? Yes, sir. Okay. Those are those 2 points. So the one they have up here in the book is x squared plus 2x minus 8. They factored it, they solved it. Got x equals 2, x equals negative 4. Look at the cute little graph. That's where they cross. 2 and negative 4 as a refresh. Okay. As equations, that was it. The end. Okay. Now that they're inequalities, you have to think about that x-axis kind of like you did with inequalities when they were linear as compounds as a number line. Okay? So think of that x-axis as a number line, because essentially that's what it is. It cuts, the parabola when it cuts through, cuts your number line into how many parts? 3. One to the left of the parabola, one to the right of the parabola, one in the middle of the parabola. So once you move away from solving these by just graphing the shaded part into doing algebra with it, you have to figure out which section of that number line is the solution set to the inequality. It'll either be the middle or the outsides. Okay? Just think about it if it were shaded. If it were shaded, you would shade one of 2 places, right? You would either shade in the middle, which would be the middle section of it, or you would shade the outside of the parabola, which would be this part, all the way down here into this part. So we have x squared minus 3x, learn to talk. X squared minus 3x is less than or equal to 18. Take these as if they were equations. So do the related equations. So x squared minus 3x equals 18. When you solve a quadratic, it has to equal what? 0. So make it so. So x squared minus 3x minus 18 equals 0. This guy factors to x plus 3, x minus 6. Swing them to the other side when you separate them. X equals negative 3, x equals 6. Okay. So when they were equations, that would be it. Everybody good? Old stuff, right? Okay. When they're equations, that would be it. Now you got to think about it graphically. Think how it cuts your x-axis into 3 parts. Okay. I'm only going to do this one time. All right. So let's draw a quick little number line. Here's negative 3, and let's say there's 6. And we're going to test each section. Okay? We're going to test each section to see which one it is. All right? I'm going to start in the middle, and my favorite number in between -3 and 6 when it comes to checking is 0. So I'm going to plug 0 into my original inequality, which gives me 0 minus 0 is less than or equal to 18, which ends up being a true statement. Okay? As long as you did everything right, that should mean that the other two sections are what? Wrong. They're false when you go check them. All right? So double check them real quick. Just do some quick mental one. Okay, 10 and maybe 100 or something outrageous, you know. Just to make sure you're right and you didn't mess up on this one or mess up somewhere else. Okay? It should either be the middle or the outsides. All righty? Your final answer, though, is that actual compound inequality. So the range of answers is these in between -3 and 6. So write that as an inequality. -3 less than or equal to x less than or equal to 6. Okay, so x squared plus 11x plus 30 equals 0. You factor it out to be x plus 6, x plus 5 equals 0, which solves to x minus 6, and x equals -5. All right. Now, I said I was only doing it the one time. I'm going to do it this time too. Don't. How many put 5 before 6?
I just fixed it.
Okay. How many put 5 before 6? Miss Jansen did. You're having a rough day with
Are you
algebra.
surprised?
I'm, you know. Let's say I'm going to erase this just because I can. Let's make sure. Okay. Let's say -5 here, -6 here. Please, like, you know, check and don't go like this. Okay. Because that's wrong. Remember, we're putting on a number line, and -6 is to the left of -5. Okay. Okay, great. So, we're going to fix that then. -6, -5. And honestly, I always just, as long as it's not 0 as one of my answers, I check 0. Wherever it's at. So it's way out here.
Oh, that's smart.
I
did
I'm
-5.5.
I'm not just a pretty face, Jordan. I got a little bit of gray matter up here too. All right. So you get 0 plus 30 is greater than or equal to 0, which gives you a true, right? Okay, so that means that the right side from -5 is true, which means the left side from -6 should also be true. You can check that for you. It will be. And the middle is wrong. Okay, so your solutions are everything over here and everything over here. Now, to write that as an inequality, it's going to the outsides. So remember what type it is from way back when? It's an OR. And to do ORs, you could be true for one or the other. And you have to write out the word OR. Okay, so to write this, you have x's, come on, x's that are less than or equal to -6, because they're going to the left.
You always want us to put the x first.
Or x's that are greater than or equal to -5. Okay, the shocking revelation is this does not factor.
Did you tell me I was wrong?
Doesn't factor, so you go A is 2, B is 4, C is -5, and then you use your program, all right, and you figure it out. Now, here's the nice part. I am getting soft. You can use your decimals. Okay.
I just did it by hand.
Okay. You can use your decimals. All right. So when those decimals spit out at you, they would be -2.87
Is it with a discriminant?
and 0.87. All right. So you're as well as anybody else has done before. Okay. You guys did fine. All right. So you go once again check that point. So you find where 0 is, which would be in the middle. Okay, so you get, when you plug it in, you get -5 greater than or equal to 0, which is a false statement. So that means the outsides.
Can we have a true or false quiz just asking those questions?
What you shade, which gives you x is less than or equal to -2.87 or 0.87.
That's pretty good.